Dear students, today we learn about the 8086 microprocessor and one of it is arithmetic instruction called DAA. Its meaning is decimal adjust for addition. So first, to understand this instruction, first you need to know what is a BCD. BCD stands for binary coded decimal, right? It will be represented by 4 bits, right? The ranges are from 0 to 9. This is the basic what you know, right? Now when you are going to add two BCD numbers, I am going to add two BCD numbers, the result may not be a valid BCD. That means if you are adding two numbers, the result either lower nipple or upper nipple go more than 9, right? In that situation, in that condition, to ensure that the results remain in the BCD format, I need to use this instruction, that is DAA instruction. That's what it is given clearly. They convert the result of addition operation of two packed BCD numbers to valid BCD numbers. So this is what the instruction is doing, right? So like what is the situation, like if lower nibble of AL, that is lower nibble, if AL is greater than 9, or if you have a auxiliary flag, that is if you have a bit from third to fourth, then what you need to do is you need to add AL plus 6, right? Else, if upper nibble of AL is greater than 9, okay, 9, or if you have a carry flag, in that condition you need to add AL plus 60H, alright. This flags will be updated: sign flag, zero flag, auxiliary carry flag, parity flag and carry flag. These are the flags will be affected. So let me see one example in detail. So this instruction DAA will be using before your regular addition instruction, right? Add AL comma CL. We know that AL equal to AL plus CL. This is what this instruction is doing, right? You know. So let me, you can take AL is 73, CL is 29. You can see here AL is 73 and CL is 29, right? Now I am going to add this numbers. This is a lower nipple, this is our upper nipple, right? So this each numbers can be represented by 4 bit. Okay, this is a BCD number, this is a BCD number, because the ranges are in the ranges of 0 to 9. I am going to add, see, I am adding 9 plus 3, 12. What is the equivalent of 12 in hexadecimal? That is C, right? So you can see here this C is greater than 9. So that means you can see this condition, first condition, the lower nibble AL is greater than 9. So that means what I need to do, I want to add with 6 to convert to the valid BCD number. So you can see here I am adding 6 with the lower nibble. To add, see, 12 plus 6, 18, right? You will get 18. 18 is a decimal, right? So I want to convert into hexadecimal. So you divide with 16. So what you will get? Be getting 1 and remainder as 2, right? So when you are converting to the hexadecimal, the remainder you should represent in the least significant bit, 2, 1, right? So 2 I am writing it here and 1, right? So 9 plus 1 you will be having 10. It will be represented by A. Now you can see A is greater than 9. Now you can go this condition. If upper nibble of AL is greater than 9, that means it satisfying the second condition also. So AL is greater than 9, right? So A is greater than 9. So suppose what I need to do for that, to convert into the valid BCD numbers, I need to add AL plus 60H. So you can see here I am adding 60H along with this A2. So that means A is 10 in decimal, and 10 plus 6, 10 plus 6, 16, right? So if you convert into the hexadecimal, 16 you will get a portion 1, remainder 0. So 0 I am writing it here, 1 it's a carry, right? See, now if you add 73 plus 29, you will get 102. So it's a valid BCD numbers. So here you can see all the numbers are within the ranges of 0 to 9. So this is a way how this DAA instruction is working.